plotted out, and actual XYZ file, I'll show you later.
Sure.
Just,
Well, where do you guys want to start today? Do you want to start
You
with Kevista or with the...
I'm not ready. If you're ready, with one.
Okay, sure.
I just need to load a few things before we.
Alright. Okay, so the items I have on the list are talking about computation, doing Kevista, and then a little bit, maybe setting a couple of deadlines for ourselves for like having a presentation ready, and because I think it would be good to do a dry run, at least one or two, especially if there's 3 to 4 of us presenting. So.
Sure.
Yeah, cool. Okay, I'll show you the gist of what I've been up to with computation and where this can go. So this was the SimPEG tutorials, it is no longer the SimPEG tutorials.
Yeah.
So I've been working on moving some of the docs that were like pretty specific to SimPEG development from tutorials now to the SimPEG docs. So things like on the SimPEG practices and things like that, and like testing, and that's pretty specific to like if you want to help develop. So I've pulled that over to SimPEG. So then this will be much more like an educational resource on simulation and inversion, and then there'll be some tutorials and case studies.
So you're parsing some stuff in actual SimPEG documents to here in like a tutorial, or?
Other way around. So there used to be stuff, like I can show you some tutorials at SimPEG.xyz. This is sort of the source for, let me share my screen. So this is the source for it. So things like getting started for developers, for example, like that's actually really like if you want to help develop. So that I have moved over to SimPEG docs.
Okay.
Same thing with what's the other one I moved? Practices. It's just like testing, pull requests, that kind of thing is like again pretty development specific.
Yeah.
Yeah, so that is that. And then because this is changing its scope a little bit, I've been working on organizing it. So I'll show you like, this is the local version. This is not live right now because it's a lot of stuff. But the idea being then there's like 3 main pieces to it. So fundamentals is actually now sort of what used to be the SimPEG tutorials. So really walking through like, each step of the framework and like, here's optimization, here's finite volume. So that's all sort of now fundamentals. Tutorials would be more so things like the MT tutorial that you're working on.
Hold on, so before, so this is different, like a computation, but we're going to remove the tutorial. Is that?
Well, so like, okay, maybe this will make sense. Is like, if we look at fundamentals, all of this stuff is still here.
I see. So you're actually moving, like, but then are we still having tutorials?
Yeah.
And then you're going to move parsing some of the like things in there to here. Computation. So we're going to have actually 3 documentation for SimPEG docs.
No, so they won't anymore be like tutorials.simpeg.
Yeah. That's what I thought. Yeah.
Yeah. So that's disappeared. That's gone.
Okay, sure.
And so now there's just like the SimPEG docs, and then this is a GeoSci.
Right. So basically, like you're rearranging that tutorial.
Yeah.
Okay.
Yeah. Yeah, so then this has changed in scope a little bit, as it's bigger than just SimPEG. It'll obviously rely a lot on SimPEG, but if there's stuff then that we want to rely on other open source packages, like if we want to put in a tutorial on CSEM that relies on that EM
PyMo.
Yeah, then like that makes sense to do.
Right. Do not the fundamentals, but the on tutorials.
Right. So I think like, and this is something to chat about, and I would appreciate your guys' thoughts on, is, so there's fundamentals. We'll have notebooks, I think, associated with each of these. There'll be like just a notebooks folder, and we'll have some specific to fundamentals, some specific tutorials, and some specific to case studies. But the distinction, I guess, I see for each would be that like fundamentals are really like we're going to look at a core piece of how to actually compute something. Tutorials I would see as much more like a walkthrough step by step of this is how to solve a problem. So like MT, the 1D. And then case studies would be much more like the TKC style stuff where it's like here's now an example that we're going to walk through and give you a few more details. Do you think that that sort of division?
Fundamental.
It's incremental, yeah, that makes sense.
Tutorials, case studies. Right. Yeah, so we can even put actual case, maybe not, yeah, no. Okay.
Case.
No, I was thinking actual case histories, but we may not. Put
Yeah,
it
but
here.
that correct would be case studies, right?
Yeah.
TKC would be there.
Yeah. Because like I see these being, they can be synthetic or field data. But,
Oh, really? Okay.
like for Craig stuff or things like that, if there is a finite example that we have that is field data, but then it's not like the same full-blown case history that we would have in GeoSci that like walks through everything. This is just like we solved the problem. Here's how.
So what's the difference then between in your mind between case studies and tutorial?
Tutorials, I guess I would see more so is like a topic you want to cover, like a specific topic. So if we want to go through like processing of MT data, that's sort of a specific thing that's maybe not really a case study.
Yeah.
It doesn't necessarily
part of it.
fall into like the workflow, but it uses elements of simulation and inversion to solve the problem.
Okay. Awesome.
Yeah.
Yeah. So most of the fundamental stuff that we used in EMGeosci can fit into tutorials here, like say DC apps.
Yeah.
Wherever what we did is
Yeah.
actually fit in those tutorials. So we can basically even put it in there. Like we could use the same function, but with a different context.
Yeah, exactly. And you give like a few more details on this is how I solved it. Here's a couple things we had to think about, like the null space or whatever in the DC matrix.
Yeah.
Yeah. And then the question I also wanted to ask you guys was sort of development style and how we want to write these things. Because this is much more I see as like a mix of notebooks and RST. And so like what I could perhaps see, like for fundamentals, I think a lot of that makes sense to have it as RST. Like it is just a written
That's
document.
text.
And then we can have a set of notebooks beside it. Case studies, let's go there, let's bookend it. Case studies I actually see as being notebooks only. And then we just build it to RST. So something like what the SimPEG examples gallery is like, except starting from notebooks.
Right.
So then all you would do is have the notebook, we would build it to RST. Tutorials was one I was unsure of what you guys think is best there. In a lot of ways, I think like a notebook style thing would be good.
Yeah. Well, you've already have like quite a bit of RSTs right? On. Maybe not.
No,
like,
there's nothing. There's nothing
yeah,
that's
so,
straight out.
okay, I see.
And like these case studies, and this was something I wanted to ask you guys too. These ones, so the DC, I commented out the potential fields one because the code has changed. It wasn't running. But these, I'd be happy just to like translate into a notebook and perhaps augment the notebooks that you guys already have and use them. So that we can compile it if you're good with that.
I think we probably have notebooks. Not sure if it's going to run.
Yeah.
Maybe run. Yeah, sure.
Yeah. The testing status on the notebooks, can Travis now test notebooks, or there was something?
Well,
Yeah,
I think, yeah, we do,
We can test notebooks.
Yeah,
Yeah,
like, just having checks running.
does it run?
yeah. That's the only question I've asked. And it does, I'll check if I've updated the script. I think I can show you actually where it's failing right now and what that looks like. Just so. So right now we're only running these tests on 2.7. I'll get it running on 3 as well. But we've got the docs that are testing and then the notebooks that are testing. And so so what it'll look like when it fails is it'll capture this. So it tells you which one it failed on. And then it captures like the entire NV convert output.
Okay. Where it failed.
And then this is the cell where it failed. So.
Sounds good.
Yeah.
Cool. Where were those notebooks before? The DC and the PF.
So right now we've got docs that contains these guys. We've got content. I'll maybe pull that up a little. Case studies, fundamentals, and tutorials. So that's the RST. And then the notebooks are here. So what I would see again is do case studies, tutorials, fundamentals.
What I meant, where were they before?
Oh, they were in the SimPEG tutorials.
Okay.
Yeah. So I just moved that whole repository.
But a SimPEG example will still exist.
Yeah.
And don't want to duplicate, or is there going to be overlap between the two? Or?
I think there certainly could be. I guess like what I would see for computation is we put a little more effort into explaining like the motivation for the steps. Whereas SimPEG tutorials, I think it's actually okay to have things that are more so like you want to create a mesh, here's the steps to create a mesh,
yes.
and not necessarily have anything like talking about mesh design or whatever. That I think would be here. So.
Yeah, because I guess what's an example right now are our scripts, right? They are all the LPY files.
Yeah.
Whereas you could just translate those into a notebook with more flesh in between.
Yeah, yeah.
Sounds good.
So there's definitely some examples, like maybe some of the potential field
Yeah,
ones
I
that
don't want to
are
have to replicate. Yeah,
more
exactly.
suited for this.
Mhm.
We can do that.
Yeah, sounds good.
Okay, so then if fundamentals is RST plus notebooks on the side, tutorials as notebooks, and case studies as notebooks works.
I'm sorry.
We were just going over the what we talked about yesterday, the structure of computation, not GeoSci.xyz. So it's not live right now, but. And then do we want like a template notebook or the case studies we sort of had a template to follow in the RST.
Mhm.
So we can sort of use that same thing but translate it over to a
Yeah. Put the SimPEG logo or whatever, like logo on top.
yeah,
So
Yeah,
you can
that
have a example format that
Yeah.
it might be good to share.
Yeah.
Put a specific logo and font,
Whatever.
fonts and reference.
sure, yeah.
I think fonts and those stuff, I think we can do it later by using different CSS or whatever.
Yeah.
I was going to save us time doing it.
Yeah,
Sorry.
so
It's
probably
true.
like a raw format is better to write.
Yeah, with reference style, that's true. So we've got
So we
don't
don't,
need the same.
yeah, we don't need to.
But this is in a notebook though, right?
Yeah.
Is the idea, okay.
Yeah, so we were just using raw
Yeah.
notebook, and like, if you want to put a different format then of fonts, we could change it later
Sure.
using different CSS or
Yeah.
whatever code. Okay, sounds good.
Sounds good. Other maybe quick updates. And then Dom, do you wanna?
Yeah, we can give an update of what's happening.
Cool. So the objective function stuff is now in dev. So that means joint inversions should be working. If there's weird things though that you encounter, like all of the same functionality that was there before should still be there, but if you encounter weird things, or anything that's unexpected, yeah, let me know and we can hunt it down. Yeah, and I guess the last thing is Jared has left some comments on the processing. So it would be good to, if you guys have a chance to take a look, particularly this one, the sketch of the library.
Whoa.
Yeah, so Jared's added some thoughts, and then I've gone in and added a sketch of some pseudocode. So it'd be good to maybe get a few more opinions, and then we can hopefully get in touch with him maybe later this week or early next, and sort of start actually thinking about doing some things there.
Yeah.
Who wants to work on this? Who's going to be on that team?
Jared's motivating a lot of it. He's in touch with a few other people like Carl Kapler. And Louise Pellerin is interested. I don't know that she would be contributing code, maybe, but like still be keeping tabs on things, which would be helpful. I'm interested in helping sort of get things moving. So.
Video was here as usual.
Fun with that.
Well, I think if you can set up like some sort of good data frame here while we're doing that, that might be really valuable for all of us.
Yeah.
It's like you need some format, but yeah, it's just like it's so scattered now. On the different, which is fine, but you have some sort of common format that at least we can use. Should be good. Yeah.
Right.
Are you talking about common format for the data or for?
Data.
Yeah. Google keeps complaining forever, right? They're not dealing with data properly, or like we could do more, I guess. Is that the way it's going to take?
Yeah, well, I think that doesn't necessarily talk to our SimPEG survey class. I kind of like okay with that. But if we have a certain format, at least, like, so whatever pandas and table format, doesn't matter, but certain format, then I'm kind of fine. It's like building up some sort of simple visualization. It's like, there are different ways. For instance, DC uses survey class to visualize things, but
right.
like, yeah, it's just so scattered now. But if you have a similar data format, then it's just up to you. Okay, I could build a visualization or whatever upon that data format. So it doesn't necessarily have to be exactly the same, but if you have something, it's a good start. Probably like here, there could be some distinction where they have a raw data, which is huge. Their time series is pretty big data, like a gigabyte. Even one station is a gigabyte or more than gigabyte sometimes. So, but like what we're inverting for is going to be much smaller, right? It's I don't know, 30 frequency or 40 frequency. So there could be some difference, but like I think here we're going to bring up a lot of those kind of things, I guess. So we can sort of figure that out and then put that into a certain kind of frame or structure. That'll be like really valuable for all of us with whatever change. Yes.
Was Jared going to provide like kind of one example and like kind of a workflow through these things so that at least you've got one instance of something?
Yeah, so he's provided the workflow. We don't have a data set yet from him, but he's provided, so here is an outline of a workflow, and then he's also provided a Google Doc. going through just sort of step by step some of the things that need to be done. I can give you like a quick overview of what I was thinking, if that would be helpful. Okay, so based on Jared's comments, so if we look at this here, we've got basically starting with a time series, we have then spectral estimation and then transfer function estimation. And each of those is sort of, they're distinct things and sort of distinct pieces of a processing workflow, so I think they should basically be their own distinct base classes, but then each builds upon the next. So to get spectral estimation up and running, you need to have a time series that you input. So you instantiate it with a time series. And so a few of the things that I'm thinking with like what maybe a time series class looks like is we bring in the source data and create a data frame for that. And so like Seogi, what you were saying with large data sets, there's things that are like Dask data frames. You can interface to them the same as like a pandas data frame, but it doesn't necessarily load everything up into memory. So if it's too large to bring into memory, there's ways around that. But we can abstract that away so you can still treat it, treat them the same. Okay, so you should be able to treat this then like, so once you've created your time series, you want to be able to treat it like a data set. So you should just be able to call it and ask for like, please give me EX at this time. So similar to like the fields object in this sense, is that it's a smart array essentially. So that would be what we would accomplish here, is that you can index it and treat it as an array. A couple other things, and these would just be properties I would see it having, is that we have the source data, and so that is always something that you can ask for and have it loaded up. And so that if you want to plot sort of your original data and then whatever you've done to process it, you should always be able to easily do that. And we can do some smart things about actually like having, not actually keeping this in memory, but loading it up or whatever if you start getting large.
Okay.
Then your current data would basically be whatever is live at the moment. And so you have your processing workflow as let me put this up aside. Like what Jared's mentioned here is perhaps we're going to load up the time series, we're going to remove some pipeline noise, and then we're going to despike the data. So the current data is always going to be wherever you are. Yeah. So if you remove pipeline noise, then it'll have that removed. And then you can go to the next step and it'll just operate on, we're always going to be operating on the current data. And then one of the things that I think we want, and we can be, yeah, this is where I'd appreciate input as well, is basically having like a processing log. So step by step, we should be recording whatever steps you've taken to get to the current data. So that if you want to go back and tinker with the step, for instance, if you found like, you got all the way through, you despiked your data and you realized there's another outlier you should have removed earlier on. Like you should just be able to go back, alter that, and then rerun everything. So that would help us do that. Also, ideally, like we should be able to serialize it. So write it down, essentially, and then load it up for any other data set. So if you start with a small subset of your data and you just want to like fine tune your workflow and then want to apply it batch onto a larger scale, you should be able to basically load up your processing log and apply it. So this, I think Rowan and Franklin might have actually some good ideas on how to keep track of these things and like properly write down and record information so that, yeah, we can capture it and reuse it.
Yeah, so at the end, so you're gonna play with some sort of workflow first, probably like a small sets of data, and then you generate a workflow. Then that's actually logged by processing one. At the end of the day, you have a large data set, but you have all of the history that you've done, and you can apply that to all of the data set, without actually writing the code, but just using that log.
Yeah.
So that's actually nice.
Yeah, and then I think it lets you be a little more iterative too, because you can just go back and change the parameters you used earlier on and rerun the whole pipeline.
Yeah. Right. Okay, that sounds good.
Okay.
So are there other, what's sort of the state of the art as far as what other groups are doing with respect to just handling time series and open source resources? And these are they just generating little subroutines or things that could actually work, or are they actually thinking in more of a holistic level?
I think there's a mix. This is a good question. So the immediate analogy I'm drawing is with Madagascar. And so they do sort of, I believe, a very pipeline-oriented workflow. But it's functional rather than, and I might be speaking off base here, but I believe it's functional rather than object-oriented. So you're stringing together a series of functions. And so it's very much like a utils kind of library. Yeah, whereas object-oriented, we build up a time series and then you ask, what can I do with this time series? And so the time series keeps track of all of the things happening to itself. Yeah, but that's something that would be good to get a better feel for what other people are up to.
Who are the other groups that are really doing it? There might be the astronomy groups. Who else works with sort of extended time series?
It would be good to actually, there's the seismic.jail, Aaron and Ratio. I don't know how they're keeping track of things. Yeah, so it'd be interesting to see what they're doing there. Who else?
I think Opspire is pretty.
Opspire would be a good one to look at.
Yeah. Well, I think there are quite a few things that we could even use it just from them.
Yeah.
They've already developed quite a bit of.
Would they actually have? Opspire would have a large scale framework?
Yeah, I'm pretty sure.
Yeah.
And they've done a lot of thinking about massively parallel. So it would be good to just get a feel for what they're up to there. Yeah.
Do you have good connections with people there, or is it?
Yeah, I had a chat with one of their main developers. I forget his name now.
German guy.
Krishner. And he. He's one of their core developers. He's on Software Underground. So we're roughly in touch.
Okay.
Yeah, it's a pretty big package and pretty widely used. So there's certainly lots to learn from what they're up to.
Well, lots to learn and perhaps lots to scale. Because it does seem like with, just working with time series, there must be just a huge number of people out there who've done a lot of stuff on this.
Yeah.
Yeah, it's probably good to do their tutorials.
Yeah. Well, and even going through pandas and like if they have a list of projects that are using pandas or something like that, and seeing sort of who's depending on that, that would be good to get some ideas there, as well as DAS data frames, and see if that's actually sort of the way you want to be going.
Last year at SciPi, there were a tutorial of time series processing with pandas.
Okay.
But it was a lot of how you deal with like very long data set and like so taking care of all the dates, and after that doing like very simple operation like moving average, FFT, and this kind of thing.
Yeah, which is handy.
Yes. But this, I just checked like not too long ago, and the tutorial from last year are still available online.
Okay. Yeah, if you want to maybe add that link to the issue, that would be good.
Yes.
Because it seems as if, like, if we had, I'm just not sure how much Jared could provide. I mean, so he's got a list of topics, that's fine. But there was definitely some MATLAB free software that was, you could kind of at least do some of the things.
Well, there's NTPy that actually is open source and does a number of processing steps.
Okay. Because I think what would be interesting is just like, okay, if you've got one example, something to kind of carry you all the way through with whatever code exists and whatever steps, and then you have to look at that and then look to see, okay, now if I wanted to reproduce that, so you've got your vision of like, okay, this is maybe how it would kind of integrate. This is what I'd like to call things.
Yeah.
And then to see what else is out there that have a real nice global feel of everything. Where you need to start and what you could borrow on.
So Jared is a developer of NTPy?
Yeah.
Okay.
Yeah, his GitHub handle is yeah.
Somehow I thought that was basically an EDI reader or something, right? So it didn't really have very much functionality.
I think they have a bit more.
Yeah, it seems like they do have some filters and
Yeah.
what's that decimation?
Yeah, so they do have.
empty tools for working with empty response.
So. Sorry. Notch filters. Yeah, so there's a lot of pieces.
So if you were faced with the task of inputting, like you now have an initial time series, right? And then you want to actually carry through to impedances on this, do you have enough functionality in that to do that? Or?
Don't actually know.
No, I think he said they don't.
Okay.
Yeah, it was mostly like I/O
Okay.
stuff. They have very simple filters. So I think that's the reason why he wants to build, I guess, revisit those conventional ways.
Yeah, so those look like individual utilities, right? Remove periodic noise, remove static shift.
Yeah, so this is still a lot of utils.
And those are all in Python, right?
Yeah.
And so what would be the object-oriented coding aspect of stuff like this? Is there Is there very much of that, or is it just basically using Python to make a util?
With MTPy?
Yeah.
So my impression, and I haven't spent tons of time looking at this, but my impression is it's the MT tools is a collection of utils. It's not really taking advantage of the object-oriented side of things.
Yeah, just keep looking at the function call, right? Right now it's calling a file name, just probably reading the whole file, bringing it to memory, doing an operation, and staying on it.
Yeah.
So rather than having an object and just saying this object, do this operation on it.
Yeah. Yeah, so the point is then, so if you're actually able to, have a script or something that could read in these data, do util after util, and come up with something. Okay, so you got to the end. Okay, so that's one move through, and then to be able to look at that and say, okay, now if I wanted to reprogram all of this in an object-oriented framework, then these are the kinds of things I would like to be able to do.
Yes. Dom, do you want to join the Hangout, or do you want me to give you the cord?
Which one is used? Probably Hangout.
I'll just get you to mute your mic and volume. And then, do you want me just to?
You've already sent it out.
Yeah, it's on Slack.
Where do you throw this on?
Oh, it's on general.
Yes. Sorry, guys.
So what are you going to talk about?
Keep it set so the case that you want to do for
Yeah.
UCGS. It's recorded, you can watch it there.
Okay.
That's the advantage. How do I share my screen?
So if you just go to. Perfect.
Okay. So we're starting from this, which is surface and cross-section geology. And we also have the University of Helsinki generated surfaces from 2D seismic lines. So they created a bunch of surfaces from these cross sections. I'm just going to show everything for now. So there were open surfaces, and kind of needed to simplify this a little bit.
Yeah.
They pick reflectors, but we're mostly interested at this point at just the large scale features. So all these guys here. I'm going to turn the seismic off. And show again the top map. Okay, so I think our goal for the VCGS is that we would like to be able to see with all the geophysics that we have, can we characterize the big units? So the peridotype, the intrusion, where the mineralization is, are these two units. So we have an olivine rich and a gabbro beneath it. And the mineralization is within all those circles here. Those are sets. In terms of data, with like the raw data, that I don't think we're going to be working with right now, but there's a VTEM survey.
Okay, good coverage then.
Yeah,
It's a big data.
it's a big data set. I'm just gonna cycle through the channels quickly.
So those lines, like those vertical lines, are also V10 though?
Yeah, they made a grid, right, when they.
Whoa. That's really tight spacing.
We had colors yesterday. Why are we not seeing colors now?
You probably like elements go upper, or is it starting after?
I thought we were already in the money here, but. Okay, now we got a little technical. Oh, it's DBDT that we want to see. Okay, there we go. So from the top again. Wow, I'm having trouble today, but basically we have 30-something time channels of V10 data. And just looking at the data, we noticed yesterday that it's really the symmetry units that are highlighted. So we might use it. We already have an inverted model from CGI that we got from them. So this is their inverted connectivity. The horizontal section. So yeah, the correlation with the sets is really good.
Mm-hmm.
Just gonna do this here quick. Like these. Like these. So yeah, all the high connectivities are in there. The intrusion itself is slightly resistive. Although we noticed a bump in the connectivity anomaly right where the mineralization is, so the mineralization itself might be slightly conductive.
Okay.
So that's the connectivity. Then we have grav. Just gonna go quickly through the data and grav. Wow. I'm having trouble. This is the gravity anomaly. So the intrusion is high density. And then we've inverted it already, this data set. We're gonna have a ABC model.
And so both what were those two units, the dark and the light gray? The gabbro and the...
Yeah, so you'll see, I'll bring up the, I have just loaded gravity. Now I can't find them. Sorry, guys.
No worries.
I had it 2 seconds ago. Oh, it's right there. Yeah, I have it already. Okay. So this is a gravity inversion. It's mislabeled. And if I put back the geological surface.
Oh yeah, it really outlines that. Wow.
Yeah, and the neat thing is that I believe I haven't really spent much time on it, but that bowl really is going to fit really well with the surface. With the surface. this guy.
Huh.
So it's bleeding out because it's smooth, but at least we're getting the edges of them.
Nice.
Okay, so that's that, and then finally we have a ground and airborne mag. So this is airborne mag, and this is the ground mag. Ground mag is like there's so much detail in them.
Wow.
For me, it's interesting because the strong negatives here, it's remnants, so that's what I'm going to invert it for. And then we have borehole. We have lots of boreholes. I'm just going to tap this, with downhole density, IP. Can do it, IP. It's really focused on where the mineralization is, but if you notice, all the strong IPs are inside here. It's spaghetti a little bit, but Maxus. Wow. Big. Maxus.
What's going on with that one well? It's like quite distinct.
This one?
Yeah.
Yeah. Yeah, it looks very distinct. It doesn't look very real. That's the thing with boreholes is that each time they survey, that's what I found. It's kind of a little bit of a separate experiment. So there might be some calibration between the. That's what we have anyway.
Okay.
Yeah. Yeah, it doesn't make much sense with what's intersecting the other hole. Okay, so we went from there and then started building some surfaces. I'm just going to go back to the workflow here.
So you went in and built these surfaces?
Yeah, we built surfaces to be able to, from the surface map, I'm going to hide this. From the surface map, put all the faults in. Okay. I guess I should pop the image again. So we already had the faults mapped on the surface, right? So created them, these guys, and then created the horizons.
Vertical faults?
Some of them are tilted because we had the cross sections, right? So we have two cross sections in there. I'm just gonna hide the horizons.
And the cross sections are interpreted from seismic? Or
I'm not 100% sure where. I think they're from seismic and geoholes, but those are really geologists that are sketched out what they think is happening from surface dips, I guess, and the surfacing. So most of them are vertical, but those that they're anti-seeing the cross sections, I give them a dips. Like for instance, this guy here is the thing. Okay, and then using some of the surfaces that Elzinski gave us, for instance, the bowl of the intrusion, these guys connected them together. So I'm going to turn off what they gave us. And just turn on what we created. No, not that. Horizons. This guy. So we've mapped nine units that yesterday Seogi and I went over. We will try to use geophysics to image the intrusion, which is the olivine and the pyroxene, the metasediments, carbonate phyllite, the peridotite, and then the mafic volcanics. So what's in green? So we build a block model for this guy. From the surfaces, we just build a block model that we'll be working with. This should be in No, I don't have it. Last one that we had yesterday. Can't find my stuff. GoCAD, they change all their menus and it drives me nuts because it varies things. And now I'm completely lost. I'll show you the mesh tools. I shouldn't do that, but mesh tool does. Okay. Seogi, where are we working again? We're working.
You could, yeah. See, research. Yeah, that one.
So we built a block model of the 25 meters on the 25 meter cell size, which we'll start populating with physical properties.
It's a big model. It's 500 by 400 by 100, so it's fairly big.
Okay.
Even visualization has a hard time.
And so these pink guys,
Those are mineralized.
It would be mineralization, yeah. And so we have that information from the 4 through 101s, their public report. They published sections of mineralizations. I'm just gonna hide
and how thick would those be?
let's measure it. Good question. Good question.
Well, that's fairly thick. I think it's 50 meters-ish. Some of them, like there could be some like 100 meters.
Yeah, you're right. 100. These big guys are 100 meters thickness. But then the other section on the other side, they kind of thins out. Like it kind of breaks apart into smaller chunks. Yeah. So I think our idea right now is to populate this 3D volume with physical properties.
Mm-hmm.
And we'll forward model Grav, Mag, EM, or I guess DC. You want to do Sag?
Yeah. You could do EM as well.
You do DCIP?
Yeah. Well, EM, I'm not sure we don't have time.
Yeah.
I think probably like just showing a 2D DC line.
I think that would be great.
An IP should be fine.
Because from what I can see from the inversions, the lenses are going to be only an IP anomaly. They're not very conductive compared to their host.
Yeah.
They're not much more dense compared to the host, and they're not magnetic, so they'll have to be chargeable. They are chargeable.
I was reading the report, DCIP report. I'm not sure that we're actually having the data that they.
Which one?
So.
Yeah, so you see how the IP is really matching well with the section nodes.
Yeah, that's great. Oops. Oh. Okay.
Just as long as you're Thanks, sir.
So you could show.
And so the unit, the mineralization is within, it's not conductive, or is it?
Failure, let's look again at the 3D inversion.
Seems like conductive.
Yeah, it's failure resistive, I think. Let's see. Let's put that on. What? Yeah, so that bowl is let me see values. it's in the 200 meters range.
Okay, so it's fairly resistive. But then it's dense.
It's
and,
dense
not overly magnetic.
and magnetic.
And
The host is
the host
magnetic.
is
Yeah, cool. Yeah.
So mag and graph should give us the
shell.
outline, the shell,
That's
and then IP should give us the mineralization. Cool.
And then connectivity in theory, I think, would give us the sediments, the outline of the sediments.
Okay.
Yeah. So that would be the plan. So now we could just forward the physical properties.
I have a few questions. Can you share my screen? Because I loaded up. So this is what done generated. So those are the DCIP
Lines, nice.
And
They just missed the mineralization though.
yeah. So there are 6 lines. 1, 2, 3, 7 lines. The black dots are DCIP lines, and yellow is also that. Yellow data is actually from that XYZ data. So it seems like it's different. So I'm not sure what that data means.
Which yellows are?
Oh, here, like those yellow. Can you see that?
Oh, they did the small grid on top of the deposit.
Yeah, so I wasn't sure, like, yeah. So it seems like I got the location of DCIP, but like not quite the data. So that's fine, but if there's a way that we can get the data, actually that's probably better. Seems like a high quality data they got. And then if you zoom in, so those are where we got the mineralization. Got the data of those location and then another location, another lines. So we could invert that. Yeah, so I wasn't sure, like, do you have a way to get the data? Is it like it's done, or like, do you have some person that you can ask? Like, or we could double check. I'm not sure what we have.
I'll double check.
So that's probably good. So what I'm planning is, like, I'm gonna pick this line which crosses the mineralization, and then probably just do 2D DC inversion and show the data and IP synthetic. And if you have,
And for physical properties, it probably goes from the well logs?
that's probably what we could do. If you can load it, we can load it in those core sample data. Yeah, make some plots and then have reasonable values of each units. They probably like classify it as units. In the
Yeah, the classification is obviously way more complicated than.
I see. Yeah, I don't know. I'm not sure, but like we could actually like read some report, and then if there are some reasonable values, we could assign. Not. Yeah. Well, anyway, we can read in those log data and actually have a look, because it's very focused on certain geological unit.
Yeah.
So we don't have much other units, but like we have pretty good proxy from V10 data, for instance. So we could actually assign that.
Right. Just keep the ratio the same. Just.
Yeah. Well, we have a qualitative values and high and low. So we could, and at least if you got a reference from V10, yeah, it's probably okay.
I have to run here shortly as well.
No, I think.
The one thing I just wanted to maybe bring up is, do we want to put a presentation template deadline? Do we want to try and sort of do a dry run next week even?
Yeah.
Even if like not everything's done, at least if the slides are there and we will talk about this or this. So that,
Yeah, that's the import driver one, yeah, because it's already, or the second, then, yeah.
yeah,
So presentation is in 2 weeks.
yeah,
Yeah, next week for sure.
that sounds good.
Yeah, next Tuesday.
Cool. The other thing I was wondering is, would you, well, first off, would you guys be game if we asked for permission to film this talk? I think it would be kind of cool to actually have a record.
Yeah, I'll ask them.
Okay, cool. Okay.
I don't see the problem.